Look at this soil, hard, cracked, the color of old concrete, the kind of ground you press a shovel into and the shovel loses. Clay heavy, compacted, baked dry in summer, and waterlogged in winter. Not a single visible sign of life. No beetles, no roots pushing through. Nothing. The kind of dirt most gardeners stare at every spring and quietly accept as their inheritance, as though bad soil is a permanent condition, like bedrock or climate. Now watch what happens when a hand fork turns over one scoop from the same bed, the same plot of earth. 90 days later, hundreds of earthworms, fat, pink, glistening, actively breeding. The soil is dark, crumbly, and it smells like a forest floor after rain. It holds together when you squeeze it and breaks apart when you open your hand. And this transformation, this complete biological reversal, cost under $40 in worm stock and about $20 in mulch materials. No tiller, no chemical fertilizer, no rototiller rental, no bags of synthetic amendments hauled home from the garden center. Under $60 total, and the system is now self-sustaining because the worms reproduce on their own and never need to be restocked again. The gardeners who have built the system report that their vegetable harvest doubled. Not improved slightly, not got a little better with some extra attention, doubled. And the soil gets richer every single season, not poorer, which is the exact opposite of what happens with chemical fertilizer. So the obvious question is this: why is not every gardener in the country doing it? Why does every hardware store in America sell bags of synthetic fertilizer and not a single one sells what actually builds soil permanently? The answer is uncomfortable, and it has more to do with economics than science. This system works too well and costs too little for anyone to make money selling it to you. Someone should have told you about this decades ago, and the fact that nobody did is honestly kind of infuriating. This video lays out the full system step by step: what to buy, where to put it, how to maintain it season after season, and the actual science of why it works at the biological level. Plus the honest downsides, because there are a few, and knowing them in advance is the difference between success and the 40 to 60% of people who fail on their first attempt. The reason this knowledge is not mainstream is genuinely structural. It is not a conspiracy theory. The chemical fertilizer industry generates over $200 billion globally every year. Their entire business model depends on farmers and gardeners buying inputs every single season. A self-sustaining worm system that costs $60 once and never needs restocking is a direct threat to that model. Nobody banned worms. Nobody held a secret meeting in a boardroom. But when the marketing budgets of chemical companies outspend agricultural extension education by 100 to 1, the result is the same. The simplest, most effective soil building technique on Earth gets buried under advertisements for products that actually degrade the very thing they claim to improve. Synthetic fertilizers reduce earthworm populations by 50 to 70% over time. That is not a side effect, that is a feature, because dead soil needs more product next year. And this is not fringe knowledge. Charles Darwin, arguably the most important biologist in human history, spent the last years of his life studying earthworms. His 1881 book, The Formation of Vegetable Mold Through the Action of Worms, made the case that worms are the single most important creature for soil fertility on the planet. Darwin called them the unsung architects of every productive field in England. The Mesoamerican farmers who built the chinampas, the floating gardens that fed entire civilizations, achieved crop yields double what surrounding farms produced, and their method was worm-rich organic soil built through exactly the kind of layering system this video will teach. There is also a specific technique involving fermented plant juice that old-time farmers used to attract worms to new ground practically overnight. That is the booster at the center of this system, and it is coming in the build instructions. But first, here is exactly what you need and what it costs. And the cost is going to surprise you. The specific species you need is Eisenia fetida, the red wiggler, not night crawlers, not common garden worms. Red wigglers are composting specialists. They eat half their body weight in organic matter every single day. They reproduce faster than any other common earthworm species, and they tolerate the confined conditions of a bed system. A pound of red wigglers contains approximately 1,000 worms and costs $25 to $40, depending on the supplier. Online vermiculture suppliers or local bait shops are the two most common sources. For a standard 4 by 8 foot raised bed, 1 pound is the starter quantity, targeting 500 to 1,000 worms per square meter of bed surface. If you are building a dedicated raised bed, the materials total $150 to $250. That is untreated lumber, cedar, or pine, never pressure treated because the chemicals kill worms, plus exterior screws and hardware cloth on the bottom to keep moles out. But here is what most videos will not tell you. You do not need a raised bed. This system works in any existing garden bed, any in-ground row, any patch of soil you're already growing in. If you skip the raised bed, your cost drops to just the worms and the mulch. The initial mulch layer of 2 to 3 inches across the full bed surface costs $10 to $20 for straw or dry leaves. Many people source this for free from fallen leaves, grass clippings from neighbors, or spent hay from local farms that would otherwise throw it away. Replenishment happens every 4 to 6 weeks at $5 to $10 per cycle, totaling $30 to $80 per year for 6 to 8 cycles. If you source your own organic matter, annual mulch cost drops to zero. The fermented plant juice booster costs almost nothing to make. A handful of actively growing plant tips, a jar, a tablespoon of brown sugar or molasses, and 7 to 10 days of fermentation time. Total material cost under $2. Kitchen scraps, coffee grounds, crushed eggshells, cardboard strips for the initial organic matter layer are all free. If you want a head start, one bag of finished compost from a garden center runs $5 to $10. Total cost summary, with existing beds, $35 to $70 in startup. With new raised bed construction, $185 to $320. Annual maintenance after year one, $30 to $80 in mulch if you buy it, or $0 if you source your own organic matter. Labor during establishment runs 1 to 2 hours per week, digging a trench, adding scraps, refreshing mulch. After 60 to 90 days, when the worm population self-sustains, labor drops to about 30 minutes per week. Compare that to conventional soil management. Tilling, fertilizing, and amending requires 5 to 10 hours per week. That is an 80% reduction in labor for a system that produces better results. The worms do the tilling for you 24 hours a day, 365 days a year, and they work for free. Producing your own worm castings costs roughly 50 cents to $1 per pound. Factoring in mulch and worm stock over the first season, store-bought compost runs $3 to $5 per pound. Premium worm castings at a garden center cost $5 to $10 per pound. You are making the most expensive soil amendment on the market for a fraction of the price, and it keeps producing indefinitely. Now you know what it costs. Here is exactly how to build it, and the specific order matters more than most people realize. Choose a location with partial shade, 4 to 6 hours of direct sunlight. Worms avoid surface heat above 85 degrees Fahrenheit, so a spot that gets morning sun and afternoon shade is perfect. Full sun works only if you commit to maintaining 3 inches of mulch year-round, which shades the soil surface and keeps temperatures down. Avoid low spots where water pools after rain. Worms need moisture, not standing water. Test existing soil with a $10 soil test kit from any garden center. Ideal pH for earthworms is 6.00 to 7.0, neutral. If your soil is below 5.5, add agricultural lime at 5 lb per 100 square feet. If above 7.5, add sulfur at 2 lb per 100 square feet. This single adjustment can mean the difference between worms thriving and worms leaving. Now the initial soil prep. This is the one time you till. Loosen the top 6 to 12 inches of soil with a broad fork or garden fork. Do not use a rototiller because it pulverizes soil structure. You are just breaking up compaction enough for the worms to get established. After this single disturbance, you will never till this bed again. The entire philosophy of the system is that the worms do the tilling from this point forward. Every time you turn soil, you destroy the tunnel networks the worms build, and those tunnels are the circulatory system of living soil. They take weeks to rebuild. One pass with a rototiller kills 50% of your worm population and erases 30 days of their work. If building a raised bed, make it 4 feet wide so you can reach from both sides without stepping in. 8 feet long, 12 inches deep. Line the bottom with 1/4-inch hardware cloth, approximately $15 for a 4 by 8 section, to keep moles out. Moles are the #1 predator of garden earthworms. Now the layering system. Layer 1, lay single-layer corrugated cardboard directly on the loosened soil surface, overlapping pieces by 4 to 6 inches. Remove any tape or staples. Wet the cardboard thoroughly so it is saturated but not floating. This does 3 things. It smothers existing weeds, it provides a slow-release carbon food source as it decomposes, and it creates a cool, dark, moist habitat that worms instinctively migrate toward. Within 2 to 3 weeks, you will find worms concentrated at the cardboard layer. Layer 2, on top of the wet cardboard, add 3 to 4 inches of mixed organic matter. The ideal mix is approximately 60% carbon-rich browns, like dry leaves, straw, shredded paper, and wood chips, and 40% nitrogen-rich greens like kitchen scraps, coffee grounds, fresh grass clippings, and crushed eggshells. Do not add meat, dairy, or oily foods because these attract rodents, not worms. A 4x8 bed requires roughly 8 to 10 cubic feet of organic matter for this layer, about 3 to 4 full wheelbarrow loads. Layer 3, spread 1 to 2 in of existing garden soil, or finish compost over the organic matter. This inoculates the bed with native soil microbes that work in symbiosis with the worms and prevents the organic layer from drying out. Layer 4, the mulch cap. Top everything with 2 to 3 in of straw, dry leaves, or shredded plant material. This is the insulation layer. It regulates temperature, retains moisture, and provides ongoing food as it decomposes into the layers below. This mulch cap must be replenished every 4 to 6 weeks. When you can see bare soil through the mulch, it is time to add more. This is the single most common failure point. Gardeners add mulch once and forget. The worms consume it, it decomposes. If it is not replaced, the food supply disappears and the worms leave. And that is just the foundation layer. The next phase is where the system starts to come alive. Introduce worms when soil temperature is between 50 and 85 bar near F. The optimal range for reproduction is 60 to 70. In most of the continental United States, that means late spring or early fall. A $12 soil thermometer inserted 4 in deep gives you the exact reading. Do not dump the worms on the surface in direct sunlight because they will die or flee. Dig 3 to 4 shallow holes, each about 4 to 6 in deep, spaced evenly across the bed. Place clusters of worms into each hole, cover lightly with moist organic matter, and immediately replace the mulch cap. The worms will distribute themselves across the bed within 48 to 72 hours. Target density is 500 to 1,000 worms per square meter. For a 408 FT bed, that is approximately 3 square meters, meaning 1,500 to 3,000 worms, or about 1.5 to 3 lb. Starting with a minimum of 1 B works fine. It just means the population takes one extra doubling cycle of 60 to 90 additional days to reach full density. In the first 48 hours, do not water. The bed should already be moist from the layering process. Check moisture by squeezing a handful of material from 3 in deep. It should feel like a wrung-out sponge. A few drops come out, but it does not pour. If it is too dry, add water with a gentle sprinkler, not a hose blast. Your worms are in the ground. They are starting to settle, but we have not added the booster yet, the component that turns a 90-day timeline into something closer to 60. Now back to the booster. Fermented plant juice is a concentrate of beneficial microbes, enzymes, and plant hormones created by lacto-fermenting fresh plant material. When diluted and applied to the bed, it supercharges microbial activity in the soil, which is the primary food source for earthworms. More microbes means more food, which means faster reproduction, which means faster population doubling. Here is how to make it. Harvest a double handful, about 200 to 300 dri, of actively growing plant tips, the top 6 to 8 in of vigorous growth. The best species are comfrey, stinging nettle, clover, or even common weeds like lamb's quarters or purslane. Chop the material roughly and place it in a wide-mouthed glass jar. Add an equal weight of brown sugar or molasses and mix thoroughly by hand, crushing the plant material to release juices. The sugar draws moisture out of the plant cells through osmosis and feeds the lactic acid bacteria that drive fermentation. Cover the jar with a cloth secured by a rubber band. Not a solid lid, because fermentation produces gas. Store at room temperature, 65 to 80°, out of direct sunlight for 7 to 10 days. You will see bubbling by day 2 or 3. When bubbling stops and the liquid smells sweet-sour like mild vinegar, it is ready. Strain through cheesecloth. The resulting amber liquid is your concentrate. Stored in a sealed glass bottle in a cool, dark place, it keeps for 6 to 12 months. To apply, dilute 1 TBSP of concentrate per gallon of non-chlorinated water. Chlorine kills the beneficial microbes, defeating the purpose. Use well water, rainwater, or let tap water sit uncovered for 24 hours to off-gas chlorine. Apply with a watering can directly to the bed surface, soaking through the mulch layer at a rate of 1 gallon of diluted solution per 10 square feet of bed. Apply once every 2 weeks during the growing season. One batch of concentrate makes approximately 50 to 75 gallons of diluted solution, enough for an entire season from a single jar. Within 24 to 48 hours of the first application, microbial counts in the top 6 increase measurably. Practitioners report worms visibly migrating toward treated areas within days. The mechanism is straightforward. More microbes mean more food, and worms follow the food. The trench method is how you feed the system long-term without buying anything. Once every 1 to 2 weeks, dig a narrow trench in the bed, 6 to 12 in deep, 4 to 6 in wide, 12 to 18 in long. Fill it with kitchen scraps, vegetable peels, fruit cores, coffee grounds, crushed eggshells, tea bags with staples removed, shredded paper, cardboard strips. Cover with 2 in of soil and replace the mulch cap. Rotate trench locations across the bed so you are never digging the same spot twice in a row. Move to a new area each week, working your way down the bed and back. Surface-deposited scraps attract flies, rodents, and raccoons. Buried scraps decompose without those problems. Worms concentrate around the buried organic matter, creating localized population booms that spread across the bed. One practitioner documented finding over 200 worms in a 6-in radius around a 2-week-old trench site. Do not bury meat, bones, dairy, oils, or cooked food. These attract rodents and create anaerobic pockets that produce hydrogen sulfide, which is toxic to worms. Citrus peels in small amounts are fine, but large quantities lower pH below the 6.0 threshold and drive worms away. Avoid glossy paper or paper with colored ink. The seasonal calendar runs like this. Spring, when soil temperature reaches 50 degrees. If starting new, build your layers now. If an existing system, pull back mulch on a warm morning and check worm activity. Introduce new worms if the population looks thin. First fermented plant juice application of the season. Resume weekly trench composting. Summer, when soil temperature runs 65 to 85 degrees. This is peak activity and reproduction. Maintain mulch at 2 to 3 full in, checking every 2 to 3 weeks. Water 1 to 2 in per week via drip irrigation or soaker hose if rainfall falls below that amount. Continue fermented plant juice applications every 2 weeks. Cocoons are hatching every 21 to 30 days, and you will see tiny, nearly transparent juvenile worms in the top 3 in. Fall, when soil temperature drops below 65 degrees. Increase the mulch layer to 4 and insulate against coming cold. Harvest castings now by scraping back the top 2 to 3 in of mulch and collecting the dark, granular material underneath. Sieve through 1 or 4 in mesh to separate worms, which go back into the bed, from castings. A 4x8 bed yields 50 to 100 labia of castings at first fall harvest. Store castings in dry conditions at 50 to 70 degrees and they keep 6 to 12 months. Winter, when soil temperature drops below 40 degrees, worms go dormant. They do not die. They burrow deeper and enter a torpor state. Add 6 in of mulch or straw for insulation in zones where soil freezes. Do not disturb the bed. In spring, they resurface when temperatures climb above 50 degrees. That is the complete build, phase by phase, but knowing what to do is not enough. Understanding why it works is what separates the people who succeed from the people who fail on their first attempt. And the science here is genuinely fascinating. Red wigglers are hermaphrodites. Every individual worm has both male and female reproductive organs. When 2 worms mate, which happens at the soil surface usually at night, both produce cocoons. Each cocoon is a tiny lemon-shaped capsule, about the size of a grain of rice, containing 2 to 5 embryos. Under stable conditions, consistent moisture, temperature between 60 and 70, adequate food, those cocoons hatch in 21 to 30 days. The young worms reach sexual maturity in 60 to 90 days and begin producing their own cocoons. This is exponential growth. Starting with 1,000 worms, you get 2,000 to 4,000 in 60 to 90 days. By month 6, you can have 8,000 to 16,000 worms in a single 4-yard FT bed. The population self-regulates based on food availability. When food runs low, reproduction slows. When you trench compost and apply fermented plant juice, you remove the food bottleneck and let the exponential curve run. As worms eat organic matter, they pass it through their gut along with mineral soil particles. The digestive process involving enzymes, beneficial bacteria, and mechanical grinding transforms raw organic material into worm castings, a stable, granular, nutrient-dense soil amendment. Castings contain 5% nitrogen, 3% phosphorus, and 2% potassium by dry weight. But here's the critical part that raw nutrient numbers miss. The nutrients in castings are in plant-available forms. When you spread synthetic 10-10-10 fertilizer, roughly 40 to 60% of those nutrients wash away before plants can absorb them. That is called leaching, and it is why chemical fertility requires constant reapplication. Worm castings bind nutrients to humic acids and microbial biomass, releasing them slowly over weeks and months. Plant nutrient uptake in worm casting amended soil is 30 to 50% higher than in synthetically fertilized soil. Rhode Island Institute research on organic no-till systems consistently shows that soils managed with biological inputs maintain fertility without external inputs, while chemically managed soils degrade over time. Every worm tunnel is a channel for air and water. A healthy worm population creates a network of burrows throughout the top 12 to 18 inches of soil, improving aeration by an estimated 40% compared to compacted worm-free soil. These tunnels function as drainage channels, moving excess water downward, preventing the waterlogging that rots plant roots. Plant roots follow worm tunnels because they are pre-made pathways of least resistance, lined with nutrient-rich castings. This is why practitioners report roots growing 20 to 50% deeper in wormwork beds. Deeper roots mean better drought tolerance, better nutrient access, and stronger plants that resist disease and pest pressure. Earthworm guts are incubators for beneficial soil microbes, bacteria, fungi, protozoa. Every casting pellet a worm deposits is a concentrated microbial colony. These microbes form symbiotic relationships with plant roots through mycorrhizal networks, extending the root systems of reach by 10 to 100 times. When you apply fermented plant juice, you seed the soil with additional lactic acid bacteria and yeast that feed the existing micropopulation, which feeds the worms, which produce more castings, which feed more microbes. It is a self-reinforcing fertility loop. Once established, this loop runs indefinitely with no external inputs except organic matter, which every garden and kitchen produces as waste. And the contrast with chemical systems is damning. Synthetic nitrogen fertilizers create salt concentrations in the soil that are toxic to earthworms. The fertilizer provides nutrients, but kills the organism that would provide those same nutrients for free, permanently. That is the economic engine behind the $200 fertilizer industry, a product that destroys the natural system it claims to replace, guaranteeing repeat purchases forever. The science is clear and the system works, but it does not work for everyone. And being honest about the failure points is more valuable than pretending they do not exist. One documented grower started with a handful of red wigglers in a no-turn raised bed. Within a 190-day growing season, the bed had a dense, visibly thriving colony. The vegetables growing in that bed, compared to an identical bed using conventional compost, showed doubled yields with noticeably deeper root systems and greener, more vigorous foliage. The before and after was dramatic enough that the grower abandoned chemical amendments entirely. But here are the honest downsides. First and most important, 40 to 60% of first-time worm systems fail. The two most common killers are overwatering and underfeeding. If soil moisture exceeds 80% field capacity, which happens when people water their worm bed the same way they water their lawn, the worms suffocate within 48 hours. They physically cannot breathe in waterlogged soil. The squeeze test must become a weekly habit until you develop an intuitive sense of the moisture level. Second, inconsistent feeding. Worms that run out of food leave. They do not wait around hoping you will remember. They migrate out of the bed within 1 to 2 weeks of the organic layer being fully consumed. The 4 to 6 week mulch replenishment schedule is not a suggestion. It is a survival requirement for the colony. If you let the mulch disappear and skip trench composting for a month, you will come back to an empty bed. Third, temperature extremes. Worms go dormant below 40 Dawson and die below 30 Sudum if the soil freezes solid. They also die above 95 degrees. In northern climates, United States Department of Agriculture, zones 3 through 5, winter insulation with 6 or more inches of straw is non-negotiable. In southern climates, zones 8 through 10, summer shade and heavy mulch are equally critical. There is no worm system that runs year-round without seasonal management in extreme climates. Fourth, pests. Moles are the primary predator and can devastate an unprotected bed in a single night. Hardware cloth on the bottom of raised beds is insurance, not optional. Ants colonize dry beds, which is a sign you are underwatering. Nematode infestations can occur in poor quality soil, treatable with neem oil solution at 1 TSP per gallon applied to the soil surface. Fifth, ecological responsibility. Red wigglers are not native to most of North America. In garden beds and compost systems, they are contained and beneficial, but dumping them into wild areas, forests, streams, natural habitats can allow them to outcompete native earthworm species and disrupt ecosystems. Keep your worms in your garden. The financial reality is this: a single 4 by 8 FRD bed producing 50 to 100 LAB of castings per season generates $100 in casting value at retail prices, or 100 to 250 at wholesale rates. Combined with doubled crop yields worth an additional $200 at farmers market prices, depending on what you grow, a $200 initial investment pays for itself in one season. After year one, input costs are essentially zero if you source your own mulch and kitchen scraps. Labor stabilizes at 30 minutes per week. The system becomes more productive every season as the worm population matures and the soil biology deepens, the exact opposite of chemical-dependent systems that degrade over time. And once a person understands that trajectory, that the system improves while doing less work every year, there is no going back to buying bags of amendments every spring. All of these downsides are manageable, every single one, if you know about them in advance. The 40 to 60% failure rate drops to 10% among gardeners who maintain consistent moisture and consistent feeding. That is the entire secret: consistency. The most expensive soil amendment on the market is the one you buy every year. The cheapest is the one that makes itself. Every bag of synthetic fertilizer you have ever purchased was a subscription to a system designed to keep you purchasing. Every earthworm in your soil is a tiny, self-replicating factory that builds fertility for free, 24 hours a day, every day, for the rest of your life. Darwin understood this 140 years ago. The farmers who built the Chinampas understood it 2,000 years ago. The only thing that changed is that someone figured out how to sell you a replacement for something that was already working. And once a person discovers that the replacement was always inferior to the original, that the soil beneath their feet was designed to feed itself if they simply stopped killing the organisms that run it, there is no going back to the old way of thinking. This is not radical gardening. This is not alternative agriculture. This is not some fringe permaculture experiment. It is the oldest system on Earth, quietly outperforming everything we have invented to replace it. If this story changed how you view the soil beneath your feet, please subscribe and like the channel. We are excavating the biological history that the industry has tried to bury. Let's cultivate a self-sustaining future together. The next hidden treasure of the garden will be revealed soon.